I do. So I'm in the box at the top of my page here. What's the very first step always when solving a quadratic? GCF. Even before GCF. Even before discriminant. Make sure it's in standard form, which means we need to check what? What do we have to make sure to be in standard form? There's a squared, that's one. Okay, all like terms are combined. What's their other requirement for standard form? The very first thing we do, even before GCF. Even before order or like terms, there's one thing we always do before anything else. There it is, equals 0. Okay? You guys are so good at it, you just forget about it. You just do it so innately. I'm not sure if I use that word right. Okay, now I want you to think about on a graph, what makes an x-intercept special? Or what makes an x-intercept an x-intercept? Like an x-intercept are the ones that cross the x-axis, right? So like if this were a graph, this would be my x-intercept. What makes that an x-intercept? Like if I have 2 points, how do I tell which one is an x-intercept? Okay. How do I know which one of those 2 points is an x-intercept? Because the y coordinate is 0. That's what makes an x-intercept special, because the y is 0. Okay? So when I solve quadratics, I'm making them equal 0. When I graph something, if it equals 0, it's an x-intercept. So guess what that means? Our answers or solutions when we solve things are our x-intercepts when we graph. So really this whole unit when we've been solving, I've been secretly getting you to find x-intercepts. That's the whole point of what we're doing. Does that make sense? Everybody good? When my equation equals 0, I can solve it. When my coordinate point has a 0 for the y, when my y equals 0, it's an x-intercept. So my answers, my solutions are my x-intercepts, where the graph will cross the x-axis. You with me? So that, let's put that together. We have certain types of quadratics that we know will have imaginary solutions, right? Does anyone remember the definition of imaginary? It's been a while since I've defined it for you. Imaginary solutions. It's okay. Imaginary numbers are non-graphable numbers, okay? So what do you think that tells me about x-intercepts for an equation if its solutions are imaginary, meaning non-graphable? You don't have to answer that yet, but I want you to keep that in mind, okay? We'll come back to that question after we do a couple examples. Everybody good? Okay, so let's find the discriminant for 1a here. So what's a? The number in front of the 1. Good. What's b? And c? Good. Now find me your discriminant. Okay, find me your discriminant. Jevin, did you grab the 11.5? It's on the counter there as you come in. Okay, I got 24. Anyone else get 24? Okay, so is that a perfect square? 25 is. So is that a perfect square? No. So how many solutions does the equation have? What do you think? Oh, come on. How many solutions does it have if it's not a perfect square? Go back and look at your 11.3 table or 11.4. This is what we've been working on the last 2 days. I know you can do it. You may not want to, but I know you can. Not a perfect square, but it's positive. So how many solutions does it have?
2.
2. And what kind?
Irrational.
Good. Irrational. Meaning they're still going to have a square root in their answer, right? Everybody good? Everybody good? Everybody good?
Yep.
Okay. So now it says, what are they? Okay, so look at 1A. What method would be the easiest to solve that one with? Yeah, you are test ready. Yeah, complete the square because A is 1 and the 2 is even. Is that familiar?
Yep.
Right, so now let's find the solutions. Okay, so I start by cutting the middle one in half. Okay, what do I do first to get the x alone?
Square root.
Even before that. That's my next step. It's close.
Add the 6.
Yep, add the 6. Good. Now I can square root my 6. Move over the 1. If you're still struggling with that, I'd love to help you outside of school sometime, but we can't spend too much time because that's what we've done. We've been working on that for 2 units. So I went a little fast. Okay, so here it says, what are the solutions? Okay, so x equals -1 plus root 6, and x equals -1 minus root 6. But now we know that those solutions represent something on the graph. I don't really know how to plot that, so I'm just going to use my calculator to help me estimate where -1 plus square root 6 is. So notice I got 1.45. And then I'll do the other one. Which is about -3.45. We doing good? Now I want to plot those. Because I know now that those are x-intercepts. So I'm going to go to the x-axis, which is here. And I'm going to plot those two x-intercepts. We're going to come back and I'm going to show you how to use your calculators to get the rest of that graph in a second. Yeah, did I do something wrong?
Isn't it supposed to be 1?
Oh, yeah. Good catch.
No.
Thank you very much. Yeah, good catch. Thank you, thank you. As your math teacher, I'm very good at counting, you know. Okay, we're going to, like I said, we're going to come back and finish the graph in a second. But let's try another one. Do you want to do another one together?
Yes.
Yeah? Okay. So let's come here and first, what's A on B? Part B. 2. And B? Yeah. And C? Good. Now find your discriminant. I'll give you a second to do that.
Don't we take out the greatest common factor?
Not yet. Only if we're going to end up doing the factoring method. What'd you guys get? Mm-hmm. 0. Good. Okay. So, anyone remember what it means when my discriminant is 0? One answer. Oh, no. One answer, multiplicity of 2. So one answer twice. So remember what that means, you guys, is we're going to have to factor it, and it's going to be the same factor. One answer, multiplicity of 2. If you want more practice on that, again, come after school or go back and look at your, in this unit, we did that on the 11.2 notes. Okay? And they're rational. They're going to be nice. Okay? So now to find them, I'm going to do what Vess said first, which is to take out my GCF. What is my GCF on this one? Good. So I start by getting rid of the 2. Okay, I've got x squared minus 4x plus 4. So I need two numbers that add to negative 4 but multiply to positive 4. And wait, remember, Natalie just told us it's not going to be 2 numbers. It's going to be 1 number twice, right? So close. Watch your negatives. Because I have to add to negative 4. Minus 2, yep. Do I need to set both parentheses equal to 0? Probably not. They're the same thing, right? So what is x going to be? What's x? Yeah, 2. Do you guys remember how to write that when it happens twice? Nope, 2m2. Oh, we could write squared if I was rewriting the parentheses, right? But I was asking how to write the answer, which is right here. Okay, so now let's make our connection with today's stuff. How many x-intercepts, then, is the graph going to have?
1.
Just 1 at 2. Okay, let's stop here for a second. Are there any questions so far?